All right, problem number 2 on the review. So this one, the setup is an object is dropped from the roof of a building, and the acceleration due to gravity is given by a of t equals minus 9.8, and it says the building is 100 meters tall, so when will the object hit the ground? So this problem has some secret assumptions that you might not notice at first. So it says the object is being dropped, so not thrown or anything like that. So if it's dropped from the building, then v of 0 is equal to 0. So let's get that out of the way. V0 is equal to 0. Also, if the building is 100 meters tall, then that tells us the initial position is 100 meters. So it secretly gave us V0 and S of 0. It also told us the acceleration due to gravity is minus 9.8 meters per second. So I have acceleration. V of t is the antiderivative of a of t, or I can write it this way. This is going to be equal to minus 9.8 t plus my constant of integration c. But I can solve for that, so let's go ahead and do that. V of 0 is equal to minus 9.8 times 0 plus c, which is also equal to 0. So this gives me that c is equal to 0. So v of t is equal to minus 9.8 t. That's my velocity function. Next up, s of t is equal to the definite integral or indefinite integral of v of t dt, because they're related by being position as the antiderivative of velocity. So same thing, this gives us that s of t must be equal to minus 4.9 t squared plus another constant of integration. S of 0 is equal to minus 4.9 times 0 squared plus c, which is equal to 100. So this gives us c is equal to 100. So we get s of t is equal to minus 4.9 t squared plus 100. We're not quite done. This problem has added in one more step, and that is s of t. We want to know when this thing is equal to 0. So we have 0 is equal to minus 4.9 t squared plus 100. 4.9 t squared is equal to 100. T squared is equal to 100 divided by 4.9. So t is equal to the square root of 100 over 4.9. And if I grab my calculator, I get square root of 100 divided by 4.9. And I get this is roughly equal to, rounding to 2 decimal places like the instructions say, 4.52 seconds. To be super pedantic, the square root, you might argue, should have a plus or minus on it. But because we're dealing with time, we're assuming time 0 and moving forward. So we pick the positive option there.